An organization has a Class B network and they wish to form a subnet for 64 departments. What would be the subnet mask? So let's see. In subnetting, we divide the network into parts. So we are dividing the network into parts. Here they are asking to split the network into 64 parts, which we need to assign to different departments. So 64 departments are there in the question, and we need to divide the network in such a way that we can separately assign the different IP addresses to different departments. So splitting can be done by reserving the bits. We will learn how and why we split a network by reserving the IP address bits. So let's see. We all know that IP addresses are unique and they are used to identify a particular network. So now IP addresses are unique, right? That's why we identify individual computers and networks using this on the internet using IP address. So IP address can be broken down into two parts. One is network ID part and another is host ID part. Now network ID part is always fixed. Network ID part is always fixed because if we change the network ID, then it would become impossible to identify the network. Host ID part can be changed and it's flexible. Host ID part can be changed based on your needs. If we fix some extra bits in the IP address, then we can assign them to parts of its network. So what they are saying is IP address consists of 32 bits. Now if you fix some of the bits in this IP address, then they can be assigned to parts of the network, right? For example, I will explain now. In the Class B network, there are 16 bits reserved for the network ID part. Now IP address is made up of 32 bits. So 16 bits are reserved for the network ID part. So how many bits are remaining for the host ID? 16, right? Now if we fix some extra bits in the IP address from the host ID part, then we can assign them to the parts of the network, right? For example, in a Class B IP address, we fix 1 bit from the host ID part because network bits are fixed, right? You can't change the network bits because that will change the destination of your packet. For example, if the network ID is changed, then your packet will go to some other network because it might be assigned to some other area or place or computer, right? So in the Class B IP address, if we fix 1 bit out of the host part of the network, then the network gets divided into two parts. One part is having a 0 bit, that is its value is represented by 0, and the other part can be identified by using a fixed 1 bit, that is 1. So you have basically divided your network into two parts which can identified. One part can be identified using a 0 bit and the other part can be identified using a 1 bit. 1 bit means its value is 1. And we can only use binary bits. So now your question must be, how can we divide it into further parts? By fixing more number of bits. If we fix 2 bits, then network gets divided into 4 parts. Why? Because you can assign different parts using this code 00011011, right? So we have divided the network into 4 parts. 4 parts how? If we fix 2 bits, then we can assign the part 1 of the network using 00, part 2 of the network using 01, part 3 of the network using 10, and part 4 of the network using 11. We can use these bits to identify the network, right? IP address is all about uniquely identifying the network. So if you have fixed some number of bits, your packet can differentiate between these 4 parts using the code of this 00011011, right? Now for further explanation, if we fix 3 bits, then we have divided the network into 8 parts. How? Using this code. For example, 000 it goes into part 0, 001 it goes into part 1, part 2, part 3, part 4, part 5, part 6, part 7. From 0 to 7 your packets are going into different departments or different parts of the network based on your reserved bits, right? And these are fixed, otherwise identifying the network parts would be impossible. So they must be fixed, right? Otherwise if you keep changing 001 to 011, then your packet will get confused and it will go from part 001 to part 3, right? So host IDs are flexible but network IDs are fixed. We have learned so far. Now using combination of 6 bits, we can divide a network into 64 parts. So first you divided the network into 2 parts using 1 bit. Then you divided the network into, so these are all in powers of 2. If you can understand, then fixing 1 bit will divide the network into 2 parts. Fixing 2 bits into 4 parts, 3, 2 to the power 3, 8 parts. So basically you keep dividing the network into powers of 2, right? So 5 bits will divide your network into 2 to the power 5, that is 32 parts. So 6 bits are required to divide the network into 64 parts. Similarly, 7 bits are required to divide the network into 128 parts. And 8 bits will, reserving 8 bits will divide your network into 256 parts, right? And if you can continue this, if you fix 10 bits, your network will get divided into 1024 parts. So octet means 8 bits and IP address has 4 octets because IP address is made up of 32 bits. So 8 bits is your octet, right? 8 octet, and IP address has 4 octets. Why? Because it's made up of 32 bits. So there are 8 bits, 8 bits, 8 bits, 8 bits, 4 octets. Now class B has 2 octets fixed. Why? Because 16 bits are reserved for the network ID part, right? So 2 bits means 8 plus 8 bits are fixed in the class B network part. And we cannot change the network part, we already know that. Now 16 bits are for net ID, network ID, and remaining 16 bits for host ID. Therefore, 255.255 part is fixed on the above options. If you look at the options, 255, this part is fixed, right? Because this is your 8 bits, 8 bits, 8 bits, 8 bits. Now first 2 octets are fixed in each option, right? Because 16 bits are fixed in class B. Let's see. So 16 bits are fixed, but because net ID cannot be changed. If you change the network ID, then the whole network will get changed, right? It will go into some other place to some other network. The packet will go to some other network. Now we need to focus on the third octet, which has 8 bits, out of which we need to reserve some for providing network identification to the 64 departments. So in the third octet, you will fix some of the 8 bits out of which out of the 8 bits, so that you can identify the network for the 64 different departments. So 64 departments are required, therefore we need to divide the network IP address into 64 parts. We need to find the number of bits which we need to reserve for splitting the network address into 64 parts. So if you fix the this MSB 6 bits, then your network will get divided into 64 parts by the reservement of this network, right? From 0 0 0 0, all these 6 zeros to 6 ones, you have divided the network into 64 parts, and we can assign them to the individual departments, right? Since the first 2 octets are network address part and we do not change the network address, in the third octet we have reserved 6 bits. Why third octet? Because first 2 octets are fixed for the network address portion. Therefore we have fixed the MSB part of the third octet. We can find decimal equivalent by reading powers of 2 from 0 to 7. So let's see what they are saying. The numbers are in powers of 2. Therefore all these binary bits are in powers of 2, right? From 0 to 7, this is 2 to the power 7, 2 to the power 6. This is 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2, in this way. So let's see. The numbers are in powers of 2. Therefore the units place is 1, 2 to the power 0, that is 1, and last place is 2 to the power 7, that is 128. So from 0 to 7 there are 8 bits, and they are from 1 to 128 in decimal. In the third octet we have fixed the initial 6 bits, that is MSB part of this octet. So we have 2 to the power 7, that is 128 plus 64 plus 32 plus 16 plus 8 plus 4 as fixed. right? 2 to the power 7, 2 to the power 6, 2 to the power 5, 2 to the power 4, 2 to the power 3, 2 to the power 2. Whereas this 2 to the power 1 is 0 and 2 to the power 0 is also 0. That is, last 2 bits are 0. So adding the first 6 bits conversion in decimal gives you 252. We can also arrive at this result by inverting our solution, that is by subtracting the power equivalent of the last 2 binary bits, right? For example, we know that all ones are 255. If you add the binary to decimal equivalent of this all ones, it's 255, but last 2 bits are 0. So subtract the last 2 bits, that is make them 1 and subtract with the 255. So 255 minus 2 plus 1 is 3, 2 to the power 1 is 2, plus 1, that is 2 to the power 0 is 3. So 255 minus 3 is 252 for 6 binary bits, digits having ones, right? So the solution for this question is option D, that is 255 this dot 255.252.0. So thank you for watching this video. I will see you in the next one. Please subscribe my channel if you found the content useful, and thank you for watching.